Okay, this is Mrs. T's Chem Talk Regents Review. This is going to be me going over the blue exam. And for those of you not in my class, the blue exam is January of 2014. So this is the beginning of the January of 2014 Regents. And for the first question, it says, what is the approximate mass of a proton? And it has four choices, two of which have the unit U, and two of which have the unit grams. U is actually the abbreviation for atomic mass units, and G is the abbreviation for grams. Now, if we look at table O, we can see on table O that a proton has the symbol 1 over 1h or 1 over 1p, and that top number is what is called the mass number, which gives us the approximate mass in atomic mass units. So that means that the approximate mass of a proton is going to be 1 U, or 1 atomic mass unit. For number 2, an electron in a sodium atom gains enough energy to move from the second shell to the third shell. The sodium atom becomes an atom in an excited state, because remember, we said if this is our nucleus and these are our rough distances for shells of electrons, anytime an electron moves from the inside closer to the nucleus to the outside further away from the nucleus, we are moving to an excited state. The original state, when the electrons are in the lowest possible energy states, would be the ground state. If electrons move further away from the nucleus by absorbing energy, they move to the excited state. And don't forget that as electrons fall back down to the ground state, they give off energy in the form of light, and that is responsible for the bright line spectrum. For number 3, which particle has no charge? Remember that a neutron is neutral. Electron has the charge of -1, positron has a charge of +1, and a proton has a charge of +1 as well. Moving on to question number 4. Which quantity represents the number of protons in an atom? That's going to be the atomic number. If we look at any symbol, remember that the top number is the atomic number. If we look at any element symbol, I misspoke, the top number, remember, is called the mass number. The bottom number will be called the atomic number. The mass number is the sum of protons plus neutrons, and the atomic number is going to be the number of protons. Number 5, in order to know what sulfur is classified as, we have to look at sulfur on the periodic table. So if we find sulfur on the periodic table, we have sulfur right here, and we said that this side of this staircase line here, we have our non-metals. The other side of the staircase, we have the metals. So that means that sulfur is going to be a non-metal. Number 6, elements in group 2 have similar chemical properties. Remember, when we talk about a group, we're talking about a column on the periodic table. These are also sometimes called families, and members of the same group are going to have the same number of valence electrons, and those valence electrons are going to determine the reactivity of those elements, and so those elements in the same group will be similar to each other for having the same number of valence electrons. What is formed when two atoms of bromine bond together? Bromine is a non-metal, and when two atoms of bromine bond together, we'll get a dot diagram that looks like this. This bond here will be considered a non-polar covalent bond. Sorry, I keep messing that up. Either way, it'll be considered a non-polar covalent bond. Those electrons will be shared equally because these two elements, these two atoms, I should say, have the same electronegativity. So they pull on the electrons equally. And this molecule will be a diatomic molecule: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine will all form diatomic molecules. Looking at number 9, which term represents the attraction one atom has for the electrons in a bond with another? This is the definition of electronegativity. And remember, we can find these values on table S. Fluorine has the highest electronegativity at 4.0, and francium has the lowest published electronegativity at 0.7. Number 10, salt water is classified as a mixture because the proportions can vary. You can call it salt water even if you have a lot of salt or very little salt. The exact proportions do not change the fact that it is called salt water, and you can have many different possibilities for the proportions, so therefore it is a mixture. For a compound, the proportions are fixed and can only be one set of proportions for one compound. Which substance cannot be broken down by a chemical change? The things that cannot be broken down by chemical change are elements, and arsenic is an element on the periodic table. Ammonia, ethane, and propanol are all going to be compounds. Number 12, some physical properties of two samples of iodine-127 and two different temperatures are shown in the table below. If we're talking about physical properties, we want to see what their phases, we want to see what's different about them. We can see that we have crystals for one of them, which is a solid, and here this one says that it is a gas, and so solid and gas are two different phases of matter. For number 13, it says that powdered iron is magnetic, but powdered sulfur is not. When they form a mixture in a beaker at room temperature, forming a mixture, the substances will retain their own original physical properties. So in a mixture, they will retain their own physical properties. They will retain their own chemical properties. We don't change their properties by making a mixture. So the iron will retain its properties that it had before it was part of the mixture. For number 14, of the average kinetic energy of the particles in a sample of matter, remember that temperature measures the average kinetic energy. This is a straight definition question, number 14. Number 15, according to the kinetic molecular theory, which statement describes the particles of an ideal gas? We know that for an ideal gas, they're moving in straight line paths. They're moving randomly. They change direction when they bounce off of something. They transfer energy when they bounce off of something. Their particles are considered not to have any forces of attraction for each other, and their movement is considered to be very random. Their individual volumes are considered to be negligible compared to the space that they're moving in. The deviations, the reason why real gases deviate from this is because their volume does matter and because they do have some attractive forces on each other. And so we know that one of the things that we can say is that their collisions may result in the transfer of energy. When one molecule collides into another, they may give energy to the other molecule. For number 16, the concentration of a solution can be expressed if we look at table T. We can find on table T the concentration section. And on table T, we see that parts per million and molarity are types of concentration. So the concentration of a solution can be expressed in parts per million. It's on table T. Two hydrogen atoms form a hydrogen molecule when they collide with sufficient energy to form a bond. This is another collision theory question. Collision theory states that in order for a reaction to happen, reacting particles must hit each other. They must hit each other with sufficient energy. That energy is the activation energy, and they must hit in proper orientation in order to have their places where they need to bond exposed to each other. Number 18, which type of formula represents the simplest whole number ratio of elements in a compound? This is the empirical formula. Remember, we said that the empirical formula was the reduced form. You take the subscripts and you reduce them as if they were all part of a fraction. So C6H12O6 would become CH2O if we divided everybody out by 6. For number 19, the coefficients in a balanced chemical equation represent the mole ratios of the substances in the reaction. Remember that if we have this would be a 2:1 mole ratio of A to C, or a 1:3 mole ratio of C to D. If they ever ask you about mole ratios of the reactants or products, they're talking about the coefficients. Number 20, when they say systems in nature tend, we're talking about the way that reactions could be thermodynamically favored. Sometimes we also call this a spontaneous reaction, and we said that the reactions tend to be exothermic, which is going to lower energy, and that they tend to become messy, which is increasing entropy. The ways that we can make things messy or increase the entropy is make more gas, make more molecules, or go from pure substances to making a mixture. Number 21, which one represents an organic compound? Remember that organic compounds are going to be carbon-based, but not carbon dioxide. For number 22, which organic compound contains nitrogen? We're going to look at table R, and we can look at the column for the functional groups. And if we go back here to table R, and we look at the functional group column, right, which is the second column, we have our amines that contain nitrogen and our amides that contain nitrogen. So either one of those could be the answer to this question, and it happens to be amine that was one of the choices. Number 23, which term identifies a type of organic reaction? That would be esterification. Remember, that's alcohol, I can't spell, plus acid makes ester plus water. Deposition is just gas going back to solid. Distillation is separating different a mixture of different substances based on the fact that they have different boiling points, and sublimation is solid to gas. Some other organic reactions would be saponification, combustion, substitution, addition, and polymerization. I'm sure I missed something, but those are some of the other organic reactions. Which compound is classified as a hydrocarbon? Remember, hydrocarbons have hydrogen and carbon only. We have some of our homologous series of hydrocarbons on table Q. And remember, we have the alkanes, which end in -ane, the alkenes, which end in -ene, and the alkynes, which end in -ine. The Al, Ol, and One are all endings from table R, and table R has our substances that are not hydrocarbons but are still organic. For number 25, in an oxidation reduction reaction, the number of electrons lost always has to be equal to the number of electrons gained. Remember, there is always conservation of mass, energy, and charge. For number 26, which substance is an electrolyte? Our electrolytes are acids, which can be found, some examples can be found on table K. Bases, which examples can be found on table L. And salts, which are ionic compounds. If those ionic compounds are soluble, they can be electrolytes as well. The ionic salts, acids and bases, would all have to be aqueous in order to be electrolytes, or the salts will also conduct electricity if they are liquids. So NaOH is the one that is our base, and it's considered an electrolyte because if we do put it in an aqueous solution, it will have the mobile ions necessary to conduct electric current. For number 27, which energy conversion must occur in the operating of an electrolytic cell? An electrolytic cell, remember, is like electroplating or recharge of a battery. So remember, these always start with electrical and change to chemical because these are the ones that are non-spontaneous. You know that you have to plug your battery in to get it to recharge. So we're starting with electricity and causing a chemical reaction. Which compound yields H plus as the only positive ions in aqueous solution? This question is giving us the definition of an areneous acid. And so we can look at table K because some of our acids are there. Acetic acid is directly on table K, but we also know that the ending COOH is an areneous acid. Or if we had H in front of either a nonmetal here or a negative ion from table E here, H in front or COOH at the end makes an areneous acid formula. For number 29, which statement describes the relative masses of two different particles? We could use table O for this, and on table O we can find the symbols for these particles. So if I scroll up to table O, we have the symbols. What do we need? We need an alpha particle, a beta particle, and a neutron. And we can see that an alpha particle's mass is 4. A beta particle's mass is listed as 0. It's 1 over 1836 of an AMU. Neutron is listed as a mass of 1 atomic mass unit. Proton is listed as a mass of 1 atomic mass unit. So if we go back to the question, we know that a beta particle has less mass than a neutron because its listed mass number is 0, where the neutron's listed mass number is 1. And finally, number 30, which term represents a type of nuclear reaction? Transmutation is a type of nuclear reaction. Some other ones would be fission, which remember is when there's neutrons on both sides and usually something with a large atomic number breaking up into two somewhat equal pieces. Fusion, which is usually H plus H making He. We also have alpha decay, beta decay, and some other types of nuclear reactions. I am going to stop here at number 30. There will be another video added shortly for the next set of questions for the blue exam.